All right, guys, today we are going to talk about graphing linear functions. All right, the past couple days we have been looking at linear functions, right? Functions that are a line. So today we're going to look specifically at how to graph them. In order to graph them, first we need to recognize that linear equations or linear functions are represented by an equation in the form y equals mx plus b, where m and b are numbers, and m we know is our slope, and b is our y-intercept. So for example, if we have the equation y equals 1/4 x plus 3, that means that the slope is 1/4 and the y-intercept is at 0, 3. Remember, y-intercepts always occur where x equals 0. So that x value is always 0 in the y-intercept. So if we have y equals negative x minus 5, that means that our slope is negative 1, right? Because there's like an imaginary 1 here. And our y-intercept would be 0, negative 5. All right, this is coming straight from this equation. So let's look at one more. Let's say we have y equals 4 plus x over 2. This one looks a little bit different, but that's okay. Remember that x over 2 is the same thing as 1/2 times x, right? So in this case, our slope, remember slope is always the one that's attached to x, so even though this one's flip-flopped, our slope is still the 1/2. And our y-intercept is 0, 4. All right, so that is just the basis of slope-intercept form of an equation, okay? So again, this right here is slope, intercept form. And that's what we're going to be using this year. So when you see a graph like we had here, all of these graphs have equations, right? But what we looked at was just the slope part of the equation. However, if we incorporated the y-intercept, we would be able to write a full equation or graph from an equation. So let's look at how to graph. Okay? So we'll just start with this first example that we had, y equals 1/4 x plus 3. So your first step is always to draw the x and y axis. All right, so, sorry, I was trying to make this on the screen here. Okay, so I'm going to draw an x and y axis. And I typically just always draw like that so you can see the entirety of the graph. Oops. Let's do this. There we go. Okay, so the first point you always graph is the y-intercept. Okay, so remember right here, this gives us our y-intercept. This y-intercept, right, in pink. Okay, so my y-intercept here is 3, which recall means 0, 3. Y-intercept means it crosses the y-axis, so that point has to be on the y-axis. So if you get confused, just remember it's on the y-axis. So it's a positive 3 on the y-axis. So 1, 2, 3, and I put a point. That's the first point from my graph. Then we're going to use the slope to determine other points. Use the slope to determine other points. All right, so our slope here is 1/4, and remember we have a rise and a run. For positive slopes, we can go up and right, or down and left. For negative slopes, up and left, or down and right. Right, because we need to make sure that this is a right hand up arrow. So a slope of 1/4, this means I rise 1 and I run 4. So I start at my y-intercept, and I'm going to rise 1, don't put the dot there, and then run 4. 1, 2, 3, 4. Put the dot there. And then I could keep going up 1 and then write 1, 2, 3, 4. Kind of goes off my graph. All right, so since I ran out of room going to the right, I did up and right. Now I can look at down and left. So go back to the first point. Go down 1 and left 1, 2, 3, 4. And remember, that's coming from right here, where our rise is 1, run is 4. Once you have about 2 to 3 points on your graph, that's enough that you can then just connect your dots, and you have successfully graphed the function. So let's try a couple more, just to make sure we're clear about what we're doing here. So let's do y equals negative 2x. Y equals negative 2x. All right, so we're going to start again by drawing our x and y axis. All right, and then the two things you need to identify are your M and your B, right? I meant to do M in purple. I'm color coding for you guys. M and B, where M is your slope and B is your y-intercept. And we always start with B. And you can remember M is always attached to X. So if we look at this case right here, we kind of are like missing a B. So that's like having a plus 0, right? So that means that our y-intercept here is really just at 0, 0, or the origin, all right? Then for our slope, remember we need a rise and a run. But if we look, we have a whole number. Anytime you have a whole number and you want to turn it into a fraction, you put it over 1. When there is no run, put it over 1. You're gonna hear me say that again. When there is no run, put it over 1. All right? So our rise here is negative 2, and our run is 1. Okay? So we start at 0, 0. That's our y-intercept. All right. Negative slope means that we can go up and left, or down and right. All right, so I start at my y-intercept 0, and if I go up 2 spaces, 1, 2, then I go left 1. up 1, 2, left 1. And you can see that that makes it a negative slope. It's going to end up going down. Then I can go back to my origin. And if I want to go in the opposite direction, go down 1, 2, and right 1. Down 1, 2, right 1. Again, I drew more points than I really need, but it just helps you to reinforce how to actually graph these things using the equation. All right, so there is y equals negative 2x. Again, we started with our y-intercept, which, because it wasn't represented here, means that it's 0. So plus 0, y-intercept represents 0, 0. Then we had a rise of negative 2, a run of 1. When there is no run, put it over 1. Rise 2, run 1. Rise 2, run 1. Okay? Let's take a peek at, let's do like 2 more examples. So we'll use the ones from our notes now. Y equals negative x minus 5. Okay, so we draw our graph. And this one, maybe you notice off the bat that our y-intercept is negative, so we might want to make sure that we have enough room on the negative side on this one. Cool. All right, so again, let's talk about our M. We'll talk about our B. Our M, remember, is our rise over our run, and our B is our y-intercept. All right, so our rise in this case, if we look, we just have like a negative for our slope. When you see a negative, that's the same thing as having negative 1x. Remember, because we don't have to write 1 when we have it as a coefficient. So this is a negative 1 slope. So again, is no run, put it over 1. So we have a rise of negative 1 and a run of 1. Okay? Our y-intercept is, again, that negative belongs to it. So it's at 0, negative 5. So remember, y, negative 5. So on the y-axis, we need a point at negative 5. So I come here, 1, 2, 3, 4, 5. I put my point. Now again, negative slope is up and left, or down and right. Now in this case, it doesn't make a whole lot of sense to go down. I can for like 1 point, but if you notice, it's just going to run us off our graph. So let's do the down first. If I go down 1, right 1, puts me right there. Now I could also go up 1, left 1, up 1, left 1, up 1, left 1, right? And that gives us a graph of the function y equals negative x minus 5. And we just connect our dots, and we have the graph. Okay, so last one that we're going to look at, y equals 4 plus x over 2. Tricky one, don't let it confuse you, remember? All right, so we're talking about still slope, y-intercept, still need a graph. This one we're pretty high in the positives, so make sure you have enough room for the positives. When I say we're pretty high in the positives, I'm talking about our y-intercept, right? So our y-intercept, we need our graph to at least have a 4 on the y-axis, right? So y-intercept is coming from this 4, so 0, 4. And then let's talk about our slope again. Remember, x over 2 is equal to 1/2 x. So that means our rise is 1 and our run is 2. And this is a positive slope, so we can go up and right, or down and left. Now, if you're curious about where this is coming from, it's just coming from our rules over here on this page that I gave you, right? That's what we know makes a positive slope. So you just need to kind of remember that. So from here, we have a y-intercept of 0, 4. So I put my point at 4 on the y. Notice my first point is never, well, with the exception of the origin, it's never on the x-axis, right? Our first point is always on the y-axis. It's the y-intercept. That's a common mistake I see is people trying to put it at 4 over here and then not knowing what to do. So remember, first point always goes on the y-axis. Okay? So now we rise 1, run 2. So rise 1, run 1, 2. And I could keep going that way, but I'm probably going to run out of room. So I'm going to come back to this point and go down 1 and left 2. All right, and then we just connect. And you really don't have to use like a straight edge like I'm doing. That's just me being particular. Cool. So then there is our graph. So again, this is graphing linear equations in slope-intercept form. Equations in slope-intercept form. Y equals mx plus b, where m is your slope and b is your y-intercept. Watch this video, take the notes, go back and rewatch as many, pause, rewind, whatever you need to do to make sure you understand and feel like you could take a handle at trying to graph some of these on your own on Monday.